Hi friends, welcome back to Acharya Gurukulam. Today's topic is linear regression analysis. In this video, I'm going to explain what is linear regression analysis, mathematical background of linear regression, performance metrics. At the end of this video, I solved a numerical problem. What is linear regression analysis? Linear regression analysis is a predictive model technique that analyzes the relationship between the target or dependent variable y and one or more independent variables x in the dataset. So here a graph is plotted between independent variable x and dependent variable y. So the red color dots indicates the data points whose coordinates are xi, yi, and the blue color line indicates the regression line having an equation y prime is equal to alpha plus beta x. The difference between the points on the regression line and the data points are yi minus yi prime. And in the equation y prime is equal to alpha plus beta x, so where alpha is equal to intercept and beta is equal to slope of the regression line. In the mathematical background, using a method of least squares, delta square is equal to sigma I is equal to 1 to n yi minus yi prime whole square, which is equal to sigma I is equal to 1 to n yi minus, as we know that yi prime is equal to alpha minus beta xi. So substitute in place of yi prime, then we'll obtain this equation. Obtain the straight line with the least squared error by minimizing the following equation for obtaining alpha and beta. So to obtain alpha and beta from this equation, we take the um, least squared error, that is dou delta square divided by dou alpha, which is equal to minus 2 into sigma I is equal to 1 to n yi minus alpha minus bxi is equal to 0. So similarly, we differentiate with respect to beta. Once we differentiate the delta square with alpha and beta, then the equations are as follows. Sigma I is equal to 1 to n, yi is equal to, we have one equation, and another equation, sigma I is equal to 1 to n, xi, yi is the another equation. Now we have two equations. So these two equations are represented in the matrix form in this manner. Now in this matrix form, the unknowns are alpha and beta. So the alpha and beta is equal to matrix inverse and the vector. Alpha and beta is equal to, after solving the inverse of this matrix, we obtain alpha and beta, and the alpha and beta equations are represented here. So this is alpha and this is beta. The terminology related to the regression analysis are as follows. So the variance, it is the sum of the squares of deviation from mean. The difference or the deviations within the data set is known as variance. So the equations are given here, SSX, SSY and SSXY. Covariance is similar to variance, but variance tells about how a single variable varies, while the covariance tells how two variables vary together. The standard deviation, it is the measure of how dispersed the data is in relation to the mean. The equations are given here. The correlation coefficient, it is the statistical measure of the strength of the linear relationship between two variables. R square is equal to SSXY square divided by SSXX and SSXY. Coming to the performance metrics, in regression analysis, the performance metrics are categorized into four. One is root mean square error. The root mean square error quantifies how the dispersed residuals are. The RMSE ranges from 0 to positive infinity value, because as the square is already taken, so we don't get any negative value. So that's why it ranges from 0 to positive infinity value. A value of 0 means that the predicted value perfectly matches the actual value. Low RMSE values indicates that the model fits the data well and how more precisely predicted. Next, R squared. R square, it is the measure of goodness of the fit of the model to the observed data. indicating how well the model predicts match the actual data points. Next one, mean absolute error, that is MAE. Here we consider the absolute value. Why we consider the absolute value means in order to avoid the positive and negative differences to cancel each other, MAE takes the absolute value of the differences. Mean squared error. Mean squared error is typically chosen as the cost function to train the mm, machine learning models. The equations are given for each and every matrix where the terms are as follows. Yi is equal to observed value, yi prime is equal to predicted value, yi bar is equal to mean value, n is equal to total number of data, SSR is sum of squares of residuals, SST is total sum of squares. Now we'll go to the example problem. A tabular column is given which consists of x and y values. The data points are 20. X is PGA, which is given in terms of centimeter per second square, and Y value is PGV, that is peak ground velocity, which is in centimeter per second. So the yellow color indicates the input value. Now to obtain alpha and beta, we need to perform a calculation. So that calculation is denoted with light green color. So these are the calculations, and after performing the calculations, we obtain alpha and beta value where alpha is equal to 0.254 and beta is equal to 0.0675. The final equation y prime is equal to 0.0675x plus 0.254. So this is the graph which is drawn between PGA centimeter per second square and PGV in centimeter per second. The equation, so this graph is uh, drawn from Excel. Y is equal to 0.0675x plus 0.2543, where r square is equal to 0.526. Now we'll see the r square value 0.526. So the extension of the problem are for calculating the performance matrix. So the calculations are here, you can see. The results are obtained from the example problem, that is RMSE is equal to 0.8682, R square is equal to 0.526, MSE 0.7538, MEA is 0.505. So the values are also calculated through MATLAB software and the values are obtained. RMSE is equal to 0.8673, R square is equal to 0.53, MSC 0.752, MEA is 0.505. Now you can see the similarity between the example problem which we solved manually and the results obtained from the software. The key takeaways from this video are the what is linear regression analysis and what is the equation for linear regression analysis and the mathematical background to obtain alpha and beta, what are the performance matrix and the corresponding equations and the similarity between the results obtained from manual calculations and software. Thank you. Jai Hind.